Welcome to all. This is our today's class is the last question on friction, or for that matter, time being, last question or last class for engineering mechanics. In case later, if I find any extra questions are required, that is in either part 1, part 2, part 3, part 4, all together more than 300, I think 320, I don't know exactly, classes are over. I divide into 4 parts. Part 1 is about force, then resolution, etc. Part 2 was, I forgot now, part 2, equilibrium part and types of load. Part 3 was centroid and moment of inertia. And in part 2, support reactions also covered. Part 3 was centroid and moment of inertia. Part 4 is running now, friction. In case I feel any extra questions required, what I will do is, I will take additional class. In the playlist, I will add it. So those people, I will keep on adding. Additional class for part 1 or part 2 or part 3 or part 4, I will tell. Now, the question is, I want to close this ladder friction chapter, that is ladder friction you are doing. But what question I am doing today, it is not only for ladder friction, it is for any friction problem. This all you have to write first. See, 1 minute. A ladder weighing 600 Newton has its bottom at 3.2 meter from wall and its top at 5 meter above the ground. This I will put later. The wall is smooth, very important. See, the wall is smooth. This is very, very important. If it is not smooth, we cannot solve this question. I will tell you later. Whereas the ground is rough. A man weighing 500 Newton is standing on the ladder at a height of 1.6 meter above the ground. Some ladder is there. It is stable, understood. See, when he is standing there, it is understood, it is stable. Okay, now, find, very important now, first time you can see, find the forces acting on the ground and wall from the ladder. Note, something is there, you should write here. This is a special type of question. It is actually asked in one university paper in Bangalore University. So many people got confused. Some people, they solved it by considering coefficient of friction. They should not consider it. I will tell you later why. So, this is a special type of question, and before I start this question solving, see, before I solve this question, that is question 111, first some important concept. Now, what all I tell, you should write. Slowly hear for everything and write. See, I will start from example 1, mini examples. This question is still pending. See, you are still pending, I will come to you later. Okay. Example 1, see. I will dictate the question. These are all not main question, all mini questions. A block weighing 200 Newton is placed on a rough horizontal surface where coefficient of friction is 0.4. Over. Find forces acting on the ground. See, find, question is, everywhere question is here. Find forces. Forces means it is plural because 2 forces are possible. Forces acting on ground. Acting on ground, question, ground from the block. From the block. Okay. What many people will do is, see here, this is a friction chapter. So do one thing. Now, see, solution briefly. You consider equilibrium of the block. See, you write here, consider equilibrium of the block. See, every question you write from beginning up now, consider equilibrium of the block or some inclined plane problem, then ladder you are writing every time, consider equilibrium of the ladder that way. Consider equilibrium of the block. Equilibrium of block. Then what you do? See, let R be normal reaction, very, very important, normal reaction, and FF, red color I put, see, I am not writing FF limit, be very careful, FF be frictional, see, frictional reacting force on the block from ground, okay, Ground, from ground, or for that matter, to make more clear, you make a note here, that is from, see, reacting forces on the block. These are reaction on the block from the ground, or from, to make more clear, that is from contact surface. Why I am telling contact surface? Because this question has got two contact surfaces. Okay. So therefore, mark here. Now write, consider free body. See, weight acting W. This is called action, 200 Newton. There is a normal reaction here, R, on the block. Then, which side friction? See, there is no question of moving. They told friction is 0.4. You know one thing, make a small note somewhere. See, somewhere you make a note here. Somewhere outside we make a note. We note, see, some separately write, note. We know that limiting frictional force, or we know that FF will become, FF limit when here the block is on the verge of moving, or it is limiting static. You can write here, limiting FF means what? See, frictional force. It is a static limiting frictional force. I already told what is FF, on the verge of moving. Then your FF limit equal to mu into normal reaction. Mu into normal reaction, or mu is coefficient of friction. See, concepts are very, very important. Now, first of all, make a note. How we defined coefficient of friction? We defined coefficient of friction as the ratio of limiting frictional force, that is, to the normal reaction. Therefore, frictional force limiting value is always lim. Okay, lim. Limiting value is always coefficient of friction mu into R. Remember, this is what? I will explain now, then I will remove this one. This is when the body is on the verge of moving. Now, add something extra. Till the stage of limiting friction reaches, your FF is not equal to FF limit. FF is not equal to FF limit. Or you can tell FF will be less than FF limit. One statement you write here, because frictional force is a self-adjusting force, and only that much frictional force will be developed which is required to prevent the motion. But in case the body is on the verge of moving, that is a limiting case, then only FF, and therefore then, see, in this case, if the stage of limiting friction is still the stage of friction, then therefore your FF is not equal to mu into R. It is less than mu into R. Mu is not considered. So this I told you. See, now come to this question. You don't know how is the frictional force. Okay, assume this way. Frictional force this way. Okay. FF. Don't put FF limit. FF. See, solve now. This I will remove now. I want more space. What all I told, you should write. If you don't write, you are losing. Remember, if it, what all I told is everything. What all I told you should write systematically, otherwise you are losing, that's all. Okay, now start solving. Sigma, see now, this body is understood to be in equilibrium. So, sigma Fy equal to 0, upward positive, if you take plus R minus 200 equal to 0, therefore your R equal to plus 200 Newton. Okay. Then sigma Fx0, take right side positive. You get Ff minus Ff equal to 0, therefore Ff equal to 0. So that mu equal to 0.4 is used to there is no frictional force acting on the block from the contact surface. Okay, now come to the last part. I write here. Therefore, see, force of activity, very important. This is what you require to do. Right, therefore, forces acting on the ground, or you can tell on the ground or on contact surface, both are same. Contact surface, very important, from the block, see, from the block will be as shown below, as shown below. That is, see, you mark the surface here, only surface. Now, very important, you should write whatever I tell. From the surface to the block, there's a normal reaction R upward. This R is force acting on the block from contact surface. From the surface or ground, if a normal reaction R is acting on the block, means the block is actually pressing the surface down. That's what they want. It is actually equal to downward force of whatever is that R equal to how much? 200 Newton. That's all right here. No friction. No friction. Or 1 minute, make a note here. Make a note here, powerful note. Later, anyway, next class onwards, we are entering strength of materials. So many questions, and also in structural analysis, and also for practical building design, when you want a concept, there is a term, you write everything. There's a term called action and reaction. Also, there are terms called supported member and supporting member. I will take a big class for that one. Completely concept based. There I will explain so many examples where I will tell you forces acting on the support. See, on the support. From the supported member. See here, this block is supported member. This ground is support. Forces acting on the support from the supported member is equal in magnitude but opposite in direction to the reaction on the supported member, either supported member or supported block or ladder, something. Equal in magnitude but opposite in direction to the reaction on the supported member from the support. Support is called supporting member. Now, furthermore, I won't explain here. We will limit to engineering mechanics now. Therefore, this case right here, for the block from the ground, an upward reaction. See here, common sense. See, when there is an upward reaction. This upward reaction came because the block is pressing the ground down. So, whatever reaction you got for the block from the ground or up, reverse it, you get the forces acting on this rough surface over. Now, here, mu has nothing to do. Why? No friction. There is no movement. Now, I'll go for example 2. Now, I will take 4 questions. A block weighing 300 Newton is placed in this surface with perimetric forces in horizontal forces 30 Newton is applied to the block pressure. 30 Newton applied like this. Find forces acting on the ground from the block. Okay, start. See, now once again. Second example, apply a force of 30 Newton. Okay, now make a note. This 30 Newton force tendency is to move the block to right side. Whether it moves the block or friction prevents it or it is on the verge of moving or already moving means dynamic friction. We don't know. So anyway, when 50 Newton is acting this way, frictional force this way. See, this FF and R has no relation. No relation. That is not connected by mu. Not connected by mu. Right now, understood, we don't know. Maybe possible. It is connected by mu. You write all this. It may be connected by mu means this FF may be mu into R. That is only when this force results in the stage of block on the verge of moving. We do not know it. Okay, start. So, sigma Fx equal to 0. Red I will not use now. Why unnecessary? Sigma Fy 0. Okay. Sigma Fy 0 upward positive. Okay. Plus R minus 200 equal to 0. Therefore, your R equal to plus 200 Newton. Sigma Fx 0, take right side positive. You got plus 300 minus Ff equal to 0, or 300, 30, not 300. 300 is gone case. 30 minus 0, therefore, your frictional force is plus 30 Newton. Okay, now, therefore, if this block is placed on the ground, if you apply a force of 30 Newton, they still told mu 0.4. See, still we are not used 0.4 because we do not know whether 30 is result in the stage of on the verge of moving. Therefore, we got. Now the answer is C. Now the forces, therefore, right here, forces acting on the ground from the block will be as shown. See, for the block, upward reaction of how much? 200 means from the block downward of 200. See, for the block, a friction force this way, left side of how much? 30 Newton means when you this way, when you apply from, it is not moving. So from the surface for the block, friction comes this way. Friction comes this way because this block is rubbing the surface like this. So this is reaction, frictional reaction. See, this is also reaction for the block. If the reaction for the block is 30 Newton left side, that means this block will what? Rub the surface this way by how much? 30 Newton. That is this force only. Correct. That is the answer. Now, 1 minute. By chance, if they ask you what is the resultant reaction, you do one thing. See. Find it and find the angle. If you cannot do it, do not continue my class. Two forces are here, one this way, see 30 this way, 30 this way, and here 200 Newton this way, right? It will be what? Resultant reaction. Not reaction, resultant force on ground is how to calculate. If you are not knowing, you have wasted your time, wasted so far, even by opening the or clicking the classes I uploaded. Don't continue in future. Okay, this is over. Now, question number 3. 3 is, I give a force P here. See now, force P. Now, question is, I read the question now. Correctly read the question first. I will dictate the question. See, this question is still pending. Okay. A block weighing 200 Newton is resting on a rough horizontal plane for where coefficient of friction between the block and the ground is 0.4. Then a force P is applied to the block. Then find for what value of P the block is on the verge of moving. On the verge of moving. Okay. Then and also this one. Find forces acting on the ground from the block. So question is, see, now be careful now. The question is find for what value of P the block is. This all we have solved earlier. For what value of P the block is on the verge of moving, and also find forces acting on the ground from the block. This is the question. Okay, now, or they may write here, instead of asking find for what value of P the block is on the verge of moving, they may ask you the least or minimum force required to move the block. This all I told you. Find the force, something found unknown when something is on the verge of moving, or find the least value or minimum value, everything same. I repeatedly told so many times. Okay, start now. Now be careful. Now the question is to find what? Question is to find what P will see that the block is on the verge of moving, right? Consider equilibrium, right here, 200 Newton, then right here, statement right. Let R be the normal reaction. See, I am dictating. Those who want to learn should write. They will tell, sir, so much writing. Yes. You want to learn, write it. Let R be the normal reaction and, see, moving this way, FFB reacting or resisting frictional force, both are on the block from the surface. Okay, right. Then write. But since it is a case of, now right here, since we have to find the value, what all I am dictating, you are right. Since you have to find the value of P for which the block is on the verge of moving, or question can be least value of P or minimum value of P required to move the block. This is a case of limiting friction, limiting static friction. Therefore, now FF will become FF limit equal to, now mu will come, mu into normal reaction, R equal to, mu is how much? 0.4 into R. See, 0.4 into R. So you write here, this FF equal to, now FF limit equal to 0.4 into R. 0.4 into R. Now correct. Okay, now solve. Therefore, sigma Fy0 upward positive, you get plus R minus 200 equal to 0. Therefore, your R equal to plus 200 Newton. And sigma Fx0, take right side positive, plus P minus 0.4 R equal to 0. Substitute R equal to plus 200 Newton. You get P equal to plus 80 Newton. Okay, over. Therefore, now 80 Newton is P. Therefore, now the normal reaction R is upward of 200 Newton and frictional force is 0.4 R is the limiting friction. See now. Now also same thing right here. Therefore, now write, force of acting ground from the block will be also upward R, downward 200. left side. Friction for the block friction is left side of 0.4. The new surface is getting a rubbing force like this of 0.4 into R equal to how much? 0.4 into R. That is R. R is 200 equal to 80 Newton. That is this P only. See, once again P only. See, you can make out. See, you will, by looking only you can make out. 200 will push the surface down. P equal to 80 Newton. You rub the surface to right side. Since it rubs the surface to right side, reaction left side. Okay, now this much is sufficient. Now make a note. Make a note. I almost explained the concept. Sufficient for engineering mechanics. But make a note here. I make a note. See, a very, very, very clear and concept based with plenty of practical examples, sometime with money matter also, will be uploaded in the YouTube. The most powerful term in structural engineering, not most, there are so many things are there, a very powerful term in structural engineering, I will tell at that time, name action and reaction, and also I will tell at that time concept of supported member and supporting member, and also I will mention there, in this all the description I will mention, or board I will write, and also I will tell reaction on supported member from supporting member, and forces transferred, forces or moment, sometimes couples also, see, and forces and or couples or moments transferred from supported member to supporting member. See, reaction on supported member from supporting member, and action or forces transferred or acting on supporting member from supported member. Very, very thorough. Such a thorough that I may use more than 2 to 3 hours for that class. Telling same thing, nothing. Then finally I will tell with a warning. If you don't follow that one, you have problem. Now all those who are studying only engineering mechanics, sufficient for you. Remember now, I will give a note for you. Note. Lastly, I will give a note. I will stop the question now. Note. In case, in any question where reactions are there, if the question is find forces acting on the contact surface or supporting member, all you have to do is find the reaction from the support. See, here support is the ground. It can be ground or some or anything. Find the reaction from the support to the member or block considered, then reverse it and apply to the support. It is the force transferred, force acting on the support. See, force acting on the support is equal in magnitude but opposite in direction to the reaction on the member or block considered from the support. This, see, and in case of friction, make a note. Unless it is given that it is a limiting friction case, frictional force FF is not equal to mu r. No, you can't take. Or then FF and R are independent unknowns. Independent unknowns. They are not connected. See, if FF equal to mu R, then only one unknown. Why? Normal reaction R, friction is mu into R. Mu is known. Only one unknown, no two unknown. Independent unknowns, or you imagine it as support reaction. Support reaction. Support reaction is normal reaction and frictional reaction. They are independent. Right here, independent. Do not write FF equal to mu R. This much is sufficient Now I will come to the last question. Question number 111. After 111, I will give one more question, 112, which you cannot solve, or I also cannot solve based on engineering mechanics concept. Some extra information required, that is statically indeterminate. Or, see, this question I will tell you now, the person who set the question should have at least common sense whether the question can be solved by using equilibrium conditions. That common sense should be there. If he sets a question which you cannot solve, you write solution, don't write solution does not exist, right? It is statically indeterminate. We cannot solve it. We cannot solve based on engineering mechanics level. What about structural engineering? Yes, structural engineering, we are solving indeterminate structures. There is some subject called structural analysis. We studied 3 subjects. Indeterminate structure 3 times. When we studied BE, it was 10 semesters, 5 years. Little later, it became 2 subjects, fully statically indeterminate structures. First propped cantilever, fixed beam, continuous beam, then frames, etc. All were coming. Moment distribution method, slope deflection method, then Carney's method, conjugate beam method, Steiner energy method, and then consistent deformation method, and so many methods were there. Even matrix method is there. That is actually once again SD method only. Matrix stiffness method, matrix flexibility method, or even solution by finite element method. This all comes in structural analysis. Engineering mechanics point of view, you write the equation, tell we cannot solve. That's all. Okay. I will now continue and start this question. Okay. Now we will start our question 111. One small note for you. I told man is standing at a height of 1.6 meter earlier. I am changing to 1.5 because, see, they told 1.6. There is one more 1.6 here. But this 1.6 is not that 1.6. Therefore, I usually do not want same numbers. So I am changing the question. See, make a note here. Question is changed. Instead of 1.6, I told 1.5. Okay, then I am adding one more data deliberately. See, the wall is smooth, whereas the ground is rough, where mu equal to 0.6. So I am telling this contact surface, this contact surface I am telling mu equal to 0.6 in the question I am giving. Okay. Now, first preliminary part. Before that, you make a note. This question, what they want, find the forces acting on the ground and wall from the ladder. So what all I told. In the question, nowhere it is mentioned that the ladder is on the verge of moving. Nowhere told. They told the person is happily standing there. See, if a stable ladder is there, if you can ask happily, see, sometime you want to take a photograph, climb the ladder, take photo, knowing that ladder is very firm. It is not on the verge of slipping. Nowhere in the question it is mentioned that ladder is on the verge of what? Slipping, and also nowhere limiting case is told. They told coefficient of friction. Yes, they can give. Coefficient of friction they can give. So what? They can give coefficient of friction. It is their right. He will tell. The person said the question, but then you can tell, sir, now it is not limiting friction. Randomly, simply a question where ladder is placed on the ground. Okay, I'll do one thing. So ladder is placed on the ground. Ladder is placed bottom at the ground, top at the wall. Wall is given smooth. Smooth, very, very important. See, the smooth is very, very important. I will tell you why. And you are asking us, a person is standing somewhere. What force are acting on the ground and wall? Yes, he will tell. Yes, I have given that way. Sir, it is not limiting. He will tell, who told it is limiting? Oh, sorry, sir. Sir, but you have given mu 0.6. He told, I can give extra data, but just because I have given mu 0.6, you should not use it. Oh, I said, unnecessary given. See, mu is always there. For every contact surface, mu is there. But it is not used. Be careful. So start. First, preliminary part you are right. Write all the note I told just now. See, now. Wall, right here. Wall ABC. You write here ABC. See, they told in the question what? In the question they told the bottom of the ladder is at 3.2 meter from the wall and top of ladder is 5 meter above. Okay, that data given. Now, weight of ladder, they told 500 Newton. See, this is weight of ladder 500 Newton. 600. 600 Newton. Okay. Weight of ladder is 600 Newton. Weight of ladder is 600 Newton. Then, see, they told weight is 600. Since no data given, it is acting to center. Length is not required. Along this length, center means lengthwise. If you project that point, it is how much? It is half of 3.2, 1.6 meter. You should write it. Okay, see. Later, see, 3.2, the weight is acting here. That is actually where the weight of ladder is acting, 1.6. Okay, then they told a man weighing 500 Newton, okay, is standing at a height of 1.5 meter from the bottom. Okay, he is standing there. He is enjoying there. Find forces acting on the wall and ground from the ladder. Forces acting on the ground, all this you have to write. Forces acting on the ground and ladder are what? Reverse. Are equal in magnitude but opposite in direction to the reaction on the ladder respectively from wall and ground. Right here. Since it is a smooth wall, there will be normal reaction RC right here. Let RC be normal reaction and make a note. Since the wall is smooth, see, they told wall is smooth. Smooth. See, if it slips, it will slip this way. Therefore, frictional force at C equal to 0. Right, a reason. There is no friction there. And let RA be normal reaction at the base. Normal reaction on the ladder. See, ladder will push it that side. That will give reaction here. Ladder will push the ground down, so reaction up. Ladder will rub the surface to left side. That's why friction force is right side, FF at A. And make a note, this FF at A is not equal to mu into RA. Very important. It is not equal to mu into RA. It is anything. That means the question given, see, when they tell man is standing there means 100% it is a case of equilibrium and also limiting stage has not reached. Only when the limiting stage is reached, then this FF will become what? Mu RA. Then mu is how much? Mu is how much mu given? Mu given is, I told 0.8. See, therefore, right here, that mu given of 0.8 is of no use to us. It is given just to confuse, or they want you to make the mistake of taking, see, this FF equal to 0.8 into RA. They want you to make you write here, they want us to take the mistake. See, in that case, what will happen is, see, they want you to take this FF equal to 0.8 times RA. They want it that way. They want you to make the mistake. Okay. So we will not make the mistake. Okay, now, primary over. Now, this is 1.5. So we want this distance. When this is 1.5, how to find this distance? See, we want this distance. I will take this distance as x dash. It is so thoroughly explained earlier. If not gone through, go through earlier. I cannot repeat same thing again and again. I told so much time, so many people who attended the class would have got bored. They would have told, sir, this is beyond the limit, sir. Explaining this much, yes, your x dash will come 0.96 meter. I calculated and entered here. See, this is x dash. That is, if you project this point here, the horizontal distance is 0.96 meter. You calculate. If you cannot calculate, don't continue my class. You are not fit to study from me. I am very harsh. See, even at the end of engineering mechanics also I am telling it. Don't come to strength of materials. Don't come. Okay, now, preliminary part is over. Okay, now start. Over, question over, nothing is there. See now, very correctly, I will give some extra information for you. See here. 1 minute. Start. I start here now. Sigma, see, sorry, one thing forgotten here. Reaction RC. Friction is not there. RC. Okay. Start. See, RA and FFA are independent reactions. Okay, now, sigma Fx equal to 0, take right side positive. Plus FFA plus FF at A minus RC equal to 0. Okay, that's all. Equation number 1. Leave it. Sigma Fy equal to 0, take upward positive. Plus RA minus 500 minus 600 equal to 0. Therefore, your RA equal to plus 1100 Newton. Okay. Then, lastly, sigma m about A0, take clockwise positive. Take moment about A. Minus RC into 5. 5 can be black color. Okay. Minus RC into 5 plus 500 into 0.96. See? RC into 5 plus 500 into 0.96. Again plus 600 into 1.6 equal to 0. You get the value of RC. How much RC will come in Newton? .500 into 0.96 plus 600 into 1.6 equal to divided by 5. 288 Newton. RC equal to plus 288 Newton. 1 minute, check once again now. I do not want mistake. 500 into 0.96 plus 600 into 1.6 divided by 5. Yes, 288 Newton. Now, lastly, substitute in 1. You get FFA minus RC. RC is how much? RC is plus 288 equal to 0. Therefore, FF at A equal to plus 288 Newton. FF at A is plus 288 Newton. Over. Now, see correctly. Therefore, I will write now here. Okay, this 1 minute now. Now, I will write the final answer now. How to find forces acting on the ground. I will write here. Therefore, force, I will put one more sketch required. Okay, I will do one thing now. Shall I remove this? I don't want. 1 minute. I want this space. This space I want. Therefore, where shall I write here? Okay, I want to tell you something now. Okay, 1 minute. See, now, the final presentation required. That is, you have to, by a sketch, you have to show forces acting on the what? On the wall and ground from the ladder. Okay, therefore, I think I can right here, no problem. See, this I remove. Okay, right here. Therefore, see, Forces acting, okay, right here, acting on ground and wall from ladder are as shown below. As shown below. Okay. FFA, how much you got? 288, no? Right here now. Therefore, FFA equal to plus 288 Newton. Okay. See, as shown here. As shown here. See, show the wall and ground. See, small sketch. See, this is the point where ladder. Don't show the ladder now. Little out of scale, 1 minute. 222 plus 288. See, this is the position of the ladder. This is the contact point A. See, this is the contact point A. This is the contact point C. This is B. See here, from the wall to the ladder, a reaction this way. So the wall will press, the ladder will press the wall like this. Equal to your RC equal to how much? RC equal to what you got? Where it? 288 Newton. And to the ladder from the ground, up reaction of RA 1100. So the ladder will press the ground down by, that is VA 110, not VA, RA. Okay. RA 1100 Newton. Then to the ladder from the ground, right side friction this way means ladder will rub it this way, a frictional force like this. FF at A. FF at A equal to 288 Newton. This is the answer. Now, by chance, if they ask you resultant reaction, resultant force, here only one force, here what you do, don't take this way, see, you have to exaggerate here, see, down and left. The resultant will be like this, see, this way. Or this much common sense is common, see, ladder, that means ladder will actually press the wall that side. That's why reaction came. Ladder will press the ground by 1100. That's why normal reaction came. Ladder will rub the ground this side. So reaction came this side. Okay, now 1 minute. Make a note here. Make a note. Right here. Right here. Our question is, that is question number 111 is completely over. Completely over. So make a note here. In future, in any, see, even limiting also in this case, okay. In any question, make a note here. Lastly, make a note. In future, in any question, if they ask us to find forces acting on the support by any, either a block or what, ladder, etc., you solve like a normal question, find reaction and consider friction. Remember, if it is limiting case, you can put FF equal to mu R. Okay. After getting the answer, reverse it and apply, you get the answer. Sufficient. Okay, now see, make a note here. Make a note. 2-3 note I want to give. I told limiting friction is not there. See, by chance, see, they have given in the question, see, mu equal to, in the question, they told mu equal to how much? 0.6. This is given just to confuse you. Or what the person who gave the question, see, if I am setting the question, I will give it. The person knows the subject, not me. Somebody gave, hear me only. So, just to confuse, purpose is to see that you make the mistake. What mistake? He wants you to make the mistake of writing right here. FF at A, he wants write what? 0.6 RA. He wants you to make the mistake. Now see, actually FF at A is not 0.6 RA. You make a note actually. See, 0.6 of RA is how much? 1100 is 660 Newton. That is limiting friction. Limiting friction has not reached. Only see, to prevent the ladder from slipping, you need a friction of only 288. Therefore, the person FF equal to 0.6A is wrong. So then, how you will solve? Then what we will do is, see here, what we will do? Sigma Fx equal, I am giving wrong solution, Fx equal to 0, see. Plus RA, sorry, you get minus RC, or some here, see, or plus 0.6 RA minus RC equal to 0, equation number 1. Then sigma Fy equal to 0, upward positive. What you get? Plus RA minus 500 minus 600 equal to 0. Therefore, RA will come how much? Plus 1100 Newton. Then immediately substituting RA over RC, substituting in 1, RC equal to how much? RC equal to 0.6 into RA. 0.6 into RA. RA is how much? 0.6 into RA is 1100. See, 0.6 into 1100 is 660 Newton. It RC will come plus 660 Newton. Then what you will do? You will present your answer like this. See here. You will tell left RC 660. So force acting on the wall from the ladder is, see, this is how you will give your answer. How? A right side force of 660 Newton here, and up RA means down force on the ground, down force of 1100, and your 0.6 RA will come 660. It is coming what? This way of 660 you will write. Then I will ask the person. Okay, that's all. Okay, now. But remember, this is wrong solution. Why? FF is not equal to mu RA. It is not equal, no data given. Now, see here. Suppose you do this way, then what about sigma m equal to 0? Oh, not used. Just because it is not used does not mean that it is not there. It is there. Therefore, do one thing. You calculate sigma m about A equal to 0. Take clockwise positive. What you get? Minus RC into 5. See. Minus RC into 5 plus 500 into 0.96 plus 600 into 1.6 equal to 0. Substitute RC equal to how much? 660 Newton. You will get, therefore, substitute. See what happens? You get nonsense. See. 660, yeah? 660 into 5 into minus 1 plus 500 into 0.96 plus 600 into 1.6. You will get minus 1860 equal to 0. Hey, what is this? Minus 1860 into 0. That means sigma m0 is not satisfied. So this ladder cannot be in equilibrium, or it is a wrong solution. That because you took FF equal to mu A, you should take, see, FF equal to mu A only in the, suppose in the question he gives, it is found that, see, suppose in the, now make one more note, this is nonsense. Now make one more note. Suppose in the question he gives, it is found that when a man weighing 500 Newton reaches the height of 1.5 meter, ladder is on the verge of slipping. Suppose he gives that way. Okay. Then, yes, then you can take FFA equal to 0.6 RA. Then you can take XF equal to what? 0.6 RA. Then I will tell him, hey, what you told? How you know it's not just slipping? I observed, I calculated. Then your what? sigma m0 is not satisfied. Or I will tell him, see, when you set a question, use structural knowledge. Sigma fx0, sigma fy0 for ladder friction, ladder problem, sigma m0, three equations are there, means there are three unknowns. You cannot give a question with the two unknowns, it becomes nonsense. Giving a question with two unknowns is nonsense. Equilibrium not maintained. By chance, see, so your question should have been, a man weighing 500 Newton is ascending the ladder, find how far he can move along the ladder before the ladder slips. In that case, you put 500 at a distance of x from here. Then one more unknown. See, now sigma m0 will give the x value. Such questions we solved. When there are three equations are there, you have to give three unknowns. You should not set a question where three equations are there but only two unknown. It is against mathematical problem. See, nobody can give, solve x plus y equal to 20 minus 2x plus 8y equal to 42 and 7x minus 7x plus 50y equal to 600. It is nonsense. It is against mathematical. See, number of unknowns should be equal to number of equations. If number of unknowns are more, no problem. In structural engineering, it becomes statically indeterminate. But if number of unknowns are lesser, equation is more, it becomes unstable structure. So, person setting the question should have at least that much basic knowledge. Okay. Now, everything over. Now I will give you question number 112, which you cannot solve. See, which you cannot solve. I will tell you why. I will use the same question. I will tell you why you cannot solve. I will write it. It will be solved within 2 minutes. Last question of engineering mechanics, question 112. Same data I am giving. A ladder weighing 600 Newton, see, has its bottom at 3.2 from wall and its top at 5 meters above ground. Coefficient of friction for contact surface with the ground and wall are, I will interchange now, ground is rough, okay, are 0.5 and 0.3 respectively. Next. A man weighing 500 Newton is standing on the ladder at a height of 1.5 meter. 1.5 means you know it's 96. Is it correct? 0.96? See, I forgot it. I will get it once again. Okay, no problem. This is how much? This is 5 meter. See how easy to find. See now. 5 divided by 3.2. 5 divided by 1.5, 1.5 correct? 1.5 into 3.2. It is 1.5, sorry, what is height? 5 height. 5 divided by 3.2 into, where is the value here? Sorry, or 1.5 height by 5 into, where is the distance here? See again, mix up here. Height of how much? 1.5. Okay. 1.5 is the height given here. So this distance you require. So 5 divided by 3.2 into 0.96 is 1.5. Correct. 0.96 meter. Sometimes it happens. Suddenly mix up comes. Okay. Now, just 1 minute. 1.5 by 0.96 equal to shift tan inverse answer. 0.5 by 0.96 equal to shift tan inverse answer. Okay, correct. Now, this question, preliminary part you write. See, I will dictate here. Let RA be the normal reaction, FFA is the frictional reaction at A, and RB is the normal reaction, FFC is the frictional reaction at C. Okay, now reason, right here. This time they are given coefficient of friction for both ground and wall. That means both are rough. See, that's all you require. Both are rough. And that 0.5 given and 0.3 given is of no use to us. You should not use it. That or a person who knows subject and who does not want give trouble to students, what he will tell? Consider both ground and wall as rough, he will tell. He may not give friction because he will give friction only to confuse you. Okay, now this all you write as usual. Now start now. See, solution. Sigma Fx equal to 0. Now what is the thing here? Last time RA, FA, now RB, one extra friction here. Okay. Sigma Fx 0. What you get? Plus FFA minus, it is RC. What is this confusion? RC minus RC equal to 0, equation number 1. Then sigma Fy equal to 0, take upward positive. I won't waste time on that one. Plus RA, then plus FFC, RA plus FFC minus 500 minus 600 equal to 0. Take equation number 2. Then sigma m about A equal to 0. Clockwise positive. Minus RC into 5. See. Minus RC into 5. Then minus F. Remember now, you should not write FFA, FFC equal to mu r. Why? It is not limiting friction. It is a stable condition. Minus FFC into what? Into 3.2. See, minus FFC into 3.2 plus 500 into 0.96 plus 600 into 1.6 equal to 0. Take equation number 3. Now, make a note here. Note. Yes, all three equilibrium conditions are over. No more equilibrium condition available. Only, so we formed 3 equations. Right here. But unfortunately, 1, 2, 3, 4. Why? These two are not connected. These two are not connected. There are 4 unknowns are there. Right here. Statement right here. Now, therefore, this question we cannot solve by using only basic conditions of static equilibrium. This is statically indeterminate. So, engineering mechanics we cannot solve. Maybe he wants that answer. Suppose somebody may tell wrong question. He will tell why wrong question? You write everything. Then write. It cannot be solved. That is the answer. I want the student to write or person writing examination to write that cannot be solved. So, no one can tell he gave wrong question. So, write here statement. Therefore, write here. There are 4 unknowns here. RA, FFA, RC, FFC, but only 3 equations available. Therefore, we cannot solve it. You write, this is indeterminate, statically indeterminate. Stop there. Okay, over. Now, suppose you write, it happens. Suppose, imagine, this question is not an examination or interview question. Imagine, you are there in the interview. You are attending. You tell him, sir, this question cannot be solved. See, you use the word sir. Okay. Then he will tell, oh, yes. Do one thing. You take one extra data. What, sir? Instead of writing, a man weighing 500 Newton is standing at a ladder at a height of 1.5 meter. You change it to a man, it is found that. You change it to, so I will tell, change the question, write it there. Okay, right. You cut this statement, see. A man weighing 500 Newton is standing on the ladder at a height of 1.5 meter, you change that language to, it is found that when a man weighing 500 Newton is standing at a height of 1.5 meter above the ground, the ladder is on the verge of slipping. Now you can solve. Sir, but sir, no, you can solve. Sir, you please solve, sir. What is there? See, since they told on the verge, then this FFA will become limiting value equal to how much? It will become how much is? 0.5 times RA. You write the sketch once again. This will become 0.3 times RC. Now you can solve, no? You will tell. If I am attending the interview, I will tell, oh yes sir. See, okay, now thank you, you will tell. So this is how questions are solved. Then I will tell him, sir, earlier you gave the question where limiting is not mentioned. I took 4 unknowns. I told we cannot solve. Okay. Then you brilliantly told the idea, change the data, this data to, it is found that when a man weighing 500 Newton is standing at a height of 1.5 from above the ground, it is on the verge of slipping. Sir, earlier you gave a question unknowingly. It is a wrong question. But unknowingly, it is not a foolish question. But this time what you told is foolish question. From a question which cannot be solved. Okay, excused. This time it is foolish question. Why? Okay, sir, then no answer is there. How many unknowns then? Then only 2 unknowns. Which one? RA and RC. Yes, so what? Sigma fx 0, sigma fy 0. You get the answer? No. Sir, we get the answer. You will ensure sigma m 0? He will tell. Huh? Then sigma m 0, how you guarantee? It may not be in equilibrium. It will not satisfy sigma m 0. See, if you use sigma fx fy 0, you get 2 answers. When you take sigma m 0, you get some other answer of RC. Oh, yes, correct. It is foolish on my part. He should tell. Correct, sir. You can tell. I never expected from you. So, I came for interview. Now I have decided not to continue the interview. I am going. Just for fun I told, don't do all those things. So this question, by changing the data, I told it is actually from a question which cannot be solved, he is changing over to foolish question. Okay. Now, so you should not do such foolish thing in any subject. Be careful. I will tell all teachers. So there are so many of my students who are lecturers. I don't tell the numbers here. Plenty. When they come to my suggestion, I will tell them always. See, if you understand everything, you solve the question without referring anything. Or, if difficulty is there, you prepare, you study. But don't randomly imagine a new concept which you cannot end it. See, you should see how I know all these things. Natural, I know it is wrong. So unless, see, if you make a blunder in the class, it is very difficult to face the students. They will be knowing sir has created blunder. But if I create a blunder in my class, offline class usually, people will be still laughing. They will tell, sir, you fooled us. See, I can escape by blunder. Why? I can tell I deliberately fooled you. Even though I made a blunder. But nothing to worry, I will not make that blunder. I got that confidence. So that's how my students got confidence in me. Even if I make a mistake, they will tell, oh, sir is joking and deliberately made a mistake. Okay. I will tell those students of me who are in teaching profession, you see that such a attitude students get about you. That is, they should get full confidence in you. Okay, now that's all. Thanks for going through the entire engineering mechanics class. So again, I told you to see that this course continues seriously further and become beneficial to all. I told earlier, share and spread this one to maximum possible. Further, I can't tell. Okay, thank you. Next, we will meet on strength of materials part.